our today's guest, Professor M.D. Zillur Rahman, Dean Earth and Environmental Science, University of Dhaka, with us. As our program, Dr. Shameem Hassan Bhuiyan is supposed to chair the session. As he is not here, I would like to request Dr. Anil Kumar Singh to chair the session. Thank you very much. And from the audience, we want to volunteer if you can volunteer to act as an assistant of the chair. Professor Shah Hussain Ahmed will assist Dr. Anil Kumar Singh. Yes, Chairman, microphone is with you. Now, I request now, because Dean today is busy today because our entrance in the university, the exam, he's supposed to leave early. So I want to give him the floor. Yes. Professor Zillur Rahman, please.
Good morning. Chair, Professor Anil Kumar Singh, Vice President, National Academy of Agriculture and Science. In this session, the rapporteur is Dr. Nirmal Chandra Shil and Professor Dr. Mustafiz Rahman, Professor, Department of Soil, Water and Environment, University of Dhaka, distinguished guests, ladies and gentlemen. Welcome to this session of the conference on climate smart agriculture in different ecosystems of South Asia. We all are aware of global warming and its result in climate change. The adverse impact of climate change are already happening in Bangladesh and South Asia. Increased frequency of flood, drought, landslide, land surface temperature rise, saltwater erosion, severe cyclone and storm surges in coastal areas of Bangladesh are the results of climate change. These impact caused disastrous situation for the inhabitants of the coastal region of Bangladesh and in South Asia. A country's food security is also related to climate change impacts. Recently, the severe flash flood in northeastern part of Bangladesh caused damage to rice crops on millions of hectares of lands. Rice is the major planted crops in Bangladesh. Its production is affected by drought in the northeastern part of Bangladesh and by saltwater erosion in the southern coastal region of Bangladesh. We need to produce climate resilient rice varieties to protect and increase rice yield. Therefore, extensive research on rice seed varieties and their tolerance limit are crucial. Climate resilience other crops can also increase the net food production of the country. Agriculture is one of the significant contributors to the annual GDP of Bangladesh, with about 20% and 60% labor forces. Research showed that agricultural production would decline due to the adverse impact of climate change, which will cause alarming situation for the country food security. Overall agricultural GDP in Bangladesh is projected to be 3.1% lower each year due to climate change. These risks will affect the agriculture sector and the way of the food chain to household consumption. To overcome this situation, we need to comprehensively assess the future climate change impact and their frequency and magnitude. We must plan our agricultural activities accordingly, such as seed hybridization, changing crop planting period, etc. Then we can increase the crops yield, grow the GDP, and achieve food security for the country. Thank you all to be present here. Thank you.
Thank you very much, Professor Muhammad Zillur Rahman, for your opening words. And I think you have set the tone for this particular session by highlighting the issues that need to be addressed as a result of the problems that are being faced by the agriculture sector as a result of climate change. Our entire South Asia, in fact, the entire world is being affected by climate change in one way or the other. So we can start with this session now. Today the first speaker was Dr. S D Attri, but he is unable to come, so we are requesting Dr. Shiv Kumar to make a presentation that Dr. Attri was supposed to make. And the topic is weather and climate extremes in South Asia. So, Dr. Shiv Kumar, the floor is yours.
Anil Kumar Singh just now mentioned Dr. Sesh Kumar Goroshi and Attri, unfortunately, they were unable to come here. So I got the PowerPoint presentation from them, and I am going to make the presentation on their behalf. And one thing is on weather and climate extremes. And in this slide, you could see that in May 2020, potential flood risk hotspots were identified. So in August, September, Pakistan was severely hit by heavy rains and experienced urban flooding with over 400 lives lost. The 400 people were lost, and around 305,000 homes are partially destroyed. So that's what happens when you have floods. So the next thing is in April 2021, potential flood risk hotspots were identified. And you could see here the states or provinces affected by floods from June to September in 2021. There's the map of India. You can't see? Slides you
We
can't
saw the
see?
first slide and then it disappeared.
Slides are not coming? Oh, there.
Yeah, now, yeah.
Yeah. So potential flood risk hotspots were identified. And you could see the map of India there in blue color. Those are all the spots where the flood risks were there. And here you see there are a lot of information provided in these various different black screens. From June to September, enormous amounts of flood risks in India in all those states. So here also you could see enormous amount of information that is provided in different states as to what is happening. And in this particular slide, very heavy and extremely heavy rainfall events in June, July, August and September 2021. And all those spots which are in blue, red, yellow and so on. For example, the light blue is June, dark blue is July, red is August, and the next one is September. And you could see in all over India, in different states, a very heavy rainfall in June, July, August, September last year. So the significant weather events in 2021, again here, you could see all along on both left side and right side, information is provided. For example, what happened in Jammu and Kashmir, in Rajasthan, in Madhya Pradesh, Gujarat, Maharashtra, Karnataka, Kerala, Uttarakhand, Uttar Pradesh, Bihar, Chhattisgarh, Telangana, Andhra Pradesh and Tamil Nadu. Those are all the information that is provided in what happened in all these states. So the next issue is tracks of cyclonic storms formed during 2021. And again you could see here information is provided on the different issues. For example, the colors there you could see on the cyclonic storms, severe storms, etc., etc. So the next issue is deficit rainfall and its impact on agriculture. So one state that they immediately mentioned is Odisha, and here rice transplantation could not be undertaken in 24 districts because of continuous subdued monsoon activity in July, August. And what you see on the left side on the graph, from June, July, August, you could see all those red ones. It shows that rainfall not there, and that is how the rice transplantation could not be undertaken. So there are upland areas, there are medium and lowland areas, and lowland direct shaded areas. In all those areas, there is the problem with lack of rain. And agriculture situation in Odisha during deep depression, that is 12 to 14 September, what is given here is Puri, Korda, Kendrapara and Jagatsinghpur. The transplanting of 40 days old seedlings for medium duration rice varieties. You can see it took 40 days old seedlings were transplanted. So because of the lack of rain, they had to wait and wait and wait. So same thing in both Baudh and Sonepur and Angul, the drainage in standing crops and shaking to vegetables. In Maharashtra, next state that is stated here is Maharashtra, and here also you could see, in Maharashtra there are affected districts, there are Dhule, Nandurbar and Jalgaon. Sowing of regular crops could not be undertaken with normal sowing window. And there are adaptive measures that were taken. For example, instead of the regular crops, sowing of pearl millet, sunflower, castor and horse gram after mid-July as contingent crops. Intercropping of sunflower and pearl millet also. And again you could see the red bar that shows the lack of rain, and that what has happened in Maharashtra also. And next state that was stated is Assam. And here a number of districts were written here: Bongaigaon, Dhubri, Hills, Nagaon, Darang, Dibrugarh, Goalpara, Jorhat, Kamrup, Morgan, etc., etc. There are a lot of impacts. Many farmers failed to transplant rice crop in medium to upland areas in time due to prolonged dry spell, and 10 to 20% reduction in Sali rice area. Next state that is shown here is Gujarat. Again here also, because of the lack of rain, the sowing was delayed and the standing crops growth is affected. And adaptive measure is, if you don't have rain, then you have to have life-saving irrigation through sprinkler methods, or in case of complete failure of timely sown crops, contingent crop sowing of sesame, castor, sorghum, fodder, pigeon pea, soybean, green gram and black gram. Again you could see here the two states, Kutch and Dahod, lot of red bars show that there was not enough rain. Next state that is mentioned is Telangana in South India. Here also there is dry spell during the mid-growing season of red gram. That is, for example, end of July and early August, and also in September. You could see the red bars where the rain was lacking. So that is a big problem in Telangana also. So next issue that until now we discussed about lack of rain. Now there is also this issue of excess rains and floods and how they impact agriculture. For example, in Andhra Pradesh, Maharashtra and Bengal, West Bengal, floods were there, and the flooded rice field in Srikakulam district in Andhra Pradesh and banana fields in Tengada, Vijayanagaram districts in Andhra Pradesh, they were all affected by the floods. Crop damage in transplanted rice fields in Polarpur block of Raigad district in Maharashtra, and you could see the pictures that are shown there. And then last issue that is mentioned is the flooded rice fields in the coastal districts of Gangetic, West Bengal, and there you could see in this slide the pictures show enormous amount of flood. So in Maharashtra also there were floods, and you could see for example in the graph there the July, 14th of July, 21st of July and 28th of July, and you could see the weekly rainfall. For example, on 21st of July in different districts, enormous amount of rainfall, and affected crop area is 1.1 lakh hectares in Maharashtra. And the crops that are affected are soybean, red gram, cotton, black gram, green gram and turmeric. So adaptive measures that are taken is the draining of excess water from the crop field and the application of 20% additional dose of nitrogen fertilizer and direct sowing of sprouted rice seeds of different varieties. And next state that is mentioned here is Madhya Pradesh, and here also you could see in the first graph enormous amount of rain that happened in different districts, and weekly rainfall departure is shown in the slide that is underneath. And affected crop area in Madhya Pradesh is 1,14,889 hectares, and the crops that are affected are drainage measures of excess water, intercultural operation and weed management. So I am showing the next slide. I am not sure why the next slide is not coming. So Madhya Pradesh I already mentioned, and West Bengal also you could see here in this slide. Because of the enormous amount of rain, crops affected are paddy, betel vine, fruits and vegetables, heavy rain and subsequent discharge of water from the dams. And there were some adaptive measures that were taken, and those are listed there: drainage of excess water to save seedlings of rice, retransplanting of short duration varieties of plants, and booster dose of urea and MOP at 150 kilograms per katta for the nourishment of damaged seedlings. In Karnataka also you could see here again lot of floods. 2.16 lakh hectares was affected, and crops affected include sugarcane, maize, green gram, soybean and tur. And there also, as the adaptive measure, is draining out excess water and weed management, cleaning of cradle pits and trenches, and chemical application to avoid fruit dropping and management of disease infestation. And next state that's mentioned here is Andhra Pradesh, and here also delayed sowing of groundnut due to excess rain in June and July, and mostly cloudy weather and poor bright sunshine hours during reproductive phase of rain-fed crops, resulting in lower yields. From 24th to 28th September in 2021, there was a very severe cyclonic storm, which is named Gul-Ab. And here the warning is heavy rainfall and gusty winds, and subdivisions affected include several states here, and all the states are listed there: Odisha, Andhra Pradesh, Telangana, Chhattisgarh, Marathwada, Vidarbha, Madhya Maharashtra, West Madhya Pradesh, Gujarat, Saurashtra and Kutch. And the damage of crops due to Gulab in coastal Andhra Pradesh and Maharashtra, you see two pictures there. On the left side, submerged paddy because of the heavy floods. On the right side, lodging in maize at cob maturity stage. The impact is that several districts are affected in both Andhra Pradesh and Maharashtra, and the crops affected in Andhra Pradesh are mainly paddy and maize, and in Maharashtra soybean, green gram and black gram. So adaptive measures, what can we do when there are these kind of things that happen? Before the cyclone, if you have floods, then you should have draining excess water from the fields, and you have to postpone harvesting and matured crops and keep harvested produce at safer places, postpone the spraying of chemicals and fertilizer applications, protect vegetable seedlings from rainfall, cover the nursery beds with polythene, and temporarily withhold the sowing of non-paddy crops, and keep to furrow weed free for easy runoff of excess water. On the right side, you could see what can be done after the cyclone. You have to raise the lodged canes and banana and lift the lodged rice and finger millet and tie 2 to 3 hills. Chemical applications for disease and pest management, booster dose of fertilizers, providing mechanical support to fruit and vegetable plants, and foliar spray of micronutrients immediately after cessation of cyclone. So here you could see what can be done in terms of technology, sending SMSs and social media messages to various farmers during deep depression and cyclonic storm, Deep depression was during 9 to 14 September 2021. In Madhya Pradesh, Odisha and Chhattisgarh, you could see how many SMSs were sent. In Madhya Pradesh, 522,307 SMSs were sent. In Odisha, 74,806 SMSs. And in Chhattisgarh, 2,13,983 SMSs. And when there was a cyclone storm Gulab, during 25 to 28 September also, enormous number of SMSs were sent. In Andhra Pradesh, 9,02,464 SMSs. In Odisha, 8,85,000 SMSs. And Maharashtra, you could see enormous number of SMSs. 31,66,840. West Bengal, 4,43,068. Chhattisgarh is low here, 36,601. Gujarat also 3,18,879. And Telangana also you could see here enormous number of SMSs, 27,85,765. Overall, when there were that cyclonic storms in all those states, total amount of SMSs sent are 84,53,702. And social media also using WhatsApp. On the next slide, you could see WhatsApp messages also. In total number of WhatsApp messages are 2,78,424. So this is what is very important. Technology is there. All of us, we use our mobile phones to send SMSs and WhatsApp messages. And this is what governments have done to send these SMSs and WhatsApp messages to all the farmers who have to take some action. And production of major kharif crops in India during 2016 to 2021, you could see on the left side the various bars are rice, next is coarse cereals, and third one is cereals, and fourth one is total food grains. And those colors show the blue color is 2016-2017, the light brown is 2017-2018, the next one is 2018-2019, yellow one is 2019-2020, and the light blue is 2021, and last one in green is 2021-2022. So agriculture output in millions of tons, and you could see here, for example, in rice, up to 100 million tons, for example, in 2021-2022, and total cereals are 140 million tons, and total food grains are 160 million tons in 2021-2022. So agriculture output is on this millions of tons, shows what is very important, that during the rainy season, what action should be taken to ensure that we have these kind of millions of tons of cereals available to the various people. The area and production of different crops in Maharashtra during 2020 and 2021. On the left side is area of different crops, and it shows in 2020 you see a big show there, the blue and light brown color, that's red gram on top, and it shows both on the top and also production in the bottom of the various different crops. So on the left side are groundnut, sorghum, red gram and black gram. On the right side is soybean and cotton. And you should see here enormous amount of production in Maharashtra in 2020 and 2021. And the change in area and production of different crops in 2021 as compared to 2020. And as you could see here, there is a lot of deviation in the area and production for groundnut, sorghum, red gram, black gram, soybean and cotton. And what you see is the downside, the light blue is deviation in area, and brown color is deviation production. And you could see that that is what happened after 2020. And Karnataka also change in area and production of different crops in 2021 as compared to 2020. And what is shown on the left side is groundnut, sorghum and black gram and area. On the right side it shows the production, and in the bottom you see all those the information is on groundnut, sorghum and black gram. So the extension of the Agriculture Advisory Service network and installation of Agriculture Advisory Service at the district level, and you could see here all over India there are 130 agro-meteorological founding units network, and in the districts also lot of information is taken. In the districts, what is important to see is that there is one agro-meteorologist, one agromet observer, and then one person who takes care of the advisory services. And on the bottom you could see the year, the existing units in 2019, 2022, 2022, 2023, and then from in future what is going to happen in terms of the district agro-meteorological units. The number of units are still going to be very important, and so for example after 2026 at the right side you could see 230,000 district agricultural meteorological units and 660 cumulative numbers. So the dissemination of agro-meteorological advisory services at present in India, it is going to 43.37 million farmers. They are getting these SMS advisories. So all those farmers must be having their mobile phones, and so they must be receiving these agromet advisory services. And the mobile apps include Megdoot, Umang, Kisan Mitra and Kisan Suvidha, and the websites are India Meteorological Department Agromet Services, and in all these states there are agricultural universities, even they have the websites where the agrometeorological advisory services are provided, and Indian Council of Agricultural Research and state departments of agriculture, they all take, they have websites, and through the websites the agrometeorological advisory services are provided. And next, mass media is shown. As you could see in India, there are 16 major languages, and all the newspapers are in the 16 languages. All the newspapers and also All India Radio, if depending on which state you are, you could listen to the language of that state, and the mass media provides information through these newspapers and radio and TV channels, enormous information to the farmers. And the next one is the Indian Fertilizer Cooperative Kisan Sanchar Limited, Reliance Foundation, and there are also non-government organizations who take some appropriate action. And next it is shown in social media, WhatsApp group is formed at block level, and it shows here the farmers covered through WhatsApp are 11,89,840. So this is what is very important. Nowadays, even many like it's shown 43.37 million farmers, they all have these kind of mobiles with them, and so they receive these WhatsApp messages and also agrometeorological advisory service information. Farmer awareness program is shown here, and it is in 2,725 places across the country during April 20 to December 2021. So here in this program there are field visits, there are demonstrations and farmer interactions and participation in Kisan Mela. And you could see on the top photograph there, these kind of farmer interaction and participation Kisan Melas are organized. You could see there a lot of farmers sitting on the chairs and then listening to information that is being provided to them. And in the second one, you could see that's in Jharkhand, and you could see women sitting there and they are listening to the information that is being provided by an advisor. And the third one, you could see there's a poster there in Karnataka. There are a lot of farmers who are around that poster, and they are going to receive this information about awareness and what they need to do depending on these various issues that we discussed earlier. The feedback of agrometeorological advisory services are in dynamic real-time, end season report and case-based feedback. And you could see here a lot of videos, and as I mentioned, television channels and also private video channels. For example, since September 2020, 323 videos on farmer feedback are uploaded on the YouTube channel of Agro-Meteorological Advisory Services. If you click on that YouTube link, you could see all those videos and farmers can be very well informed. And this is what needs to be done to help farmers. And other new initiatives to augment this geographic meteorological services, as it was mentioned, Agro-Meteorological Advisory Service, setting up these DAMU at KVKs in remaining districts, installation of Agro-Meteorological Advisory Services, impact-based forecasts, integration of state government network weather observation data, and improved weather information for agriculture. So what this shows is that there are a lot of initiatives now are being taken. For example, how can we address the issue of crops, soils, pests and diseases in these various districts, and what can be done in terms of collaboration with CRIDA, the Central Research Institute for Dryland Agriculture, and SAUs, automation of agromet advisory preparation and agromet product development. Agromet product development, very, very important, they are listed there. Developing protocols, geospatial analysis of soil moisture and soil temperature, and forecasting pest and disease infestation. So that is what is discussed in this issue of, Thank you very much.
Thank you, Dr. Shivkumar. I know it's always a tough job to present somebody else's slides, so thank you, done an excellent job. So we have a Zoom one, next one? It's supposed to be on Zoom. So Dr. Chattopadhyay?
Can you see my presentation? I am audible?
Yes, you are audible and we can see your presentations. Please go ahead.
Okay, thank you. Thank you very much. Thanks to the organizer for giving me chance. Today I'll speak about sustainable management of rainfed irrigated agriculture in South Asia, particularly in respect of climate variability and climate change. But my outline of presentation will be what will be the present status of use of quality of water. Then what is the impact of climate variability, climate change, particularly water availability in South Asia? Then what could be the possible interventions and what is the required policies, decision to be taken to offset this kind of eventualities, and then the way forward. First of all, this World Water Development Report, which has been published in 2020, clearly mentioned that water will be a great issue in future, and huge people in the world will be suffering from the water stress. There we should change our attitude, how we should use the water, and also the climate change will definitely affect that availability, quality, and quantity of the water. Now, as you all know, the South Asia is the hotspot of climate crisis because huge populations, they are working on agriculture and forest, livestock, but these sectors are very much affected by the climate variability and climate change. So there is a question of coming that what is the sustainable management we can think of it, because this is the solution in future. And the kind of things which we'll be looking at that because of climate change, that will be the land degradation, desertification, biodiversity, and so and so forth. So the thing is that ultimately my topic is, which I'm coming to my topic, is that what are the sustainable things we are thinking of, how we can preserve all these issues. Now, if you see some of the major problems of water management in South Asia, including India, is that we are using at our wish, that means flood irrigations we are doing which may not be required, then exploitation of groundwater which is not very much required, then cultivation of water intensive crop like sugarcane, rice, and insufficient water harvesting for the succeeding season, then waste of water which is going to the sea and this thing. And another very important is the salinity. I will discuss in detail. Now, this is one of the example in Punjab, in India, where they are going on the monocrop, basically the wheat, but they have started off growing rice, and they are lifting huge amount of water, and that water has been given the subsidy for electricity, and that's make a lot of headache and concern to the policy makers and others. Now you see that the contrasting is the drought because whenever monsoon is very fluctuating in South Asia, so recurrent drought is coming. But we have to have a very good, system how to making adaptations, mitigations of the drought. Now, another very important part which I mentioned that water pollution because of this increase of severe cyclone, lot of seawater intrusions are there into that, and also because a huge lifting of water from the groundwater, there are so many places that arsenic is a huge problem. So this hinders this quality of water which is required for drinking water as well as for the agriculture purpose. Now, basically, when we are coming about the climatic variability, so this kind of climatic, variability makes our agriculture very busy these days. One is that erratic onset, then a shift in the active and break cycle, then increase extreme weather and so forth. So that is the thing where agriculture is very, making unstable. Now, again, when I was talking about climate variability, the natural disaster, which is the direct or indirect effect of the climate change or climate variability, 40% of this, extreme weather is in South Asia, and which is affecting the livestock agriculture hugely, and also the ultimately the when the drought is coming, then severe water stress, particularly in the dry farming tract in the South Asia. You see that how agriculture is getting busy because this kind of system, it may be the winter system where the western disturbance is coming, when the monsoon is coming and pre-monsoon cyclone. So that makes that full your South Asia, agriculture is very sensitive. And now you see some of the examples I'm giving that how in South Asia this extreme weather is coming in a very recurring way. So seeing this, all these things, you can understand that how the extreme weather which is already prevalent and it has been focused in climate change, it will be increased. That means how much, means mitigation adaptation is required. Now, this is the, all of you know that Earth is warmed up, and this left-hand side is the last 2,000 years, and next is that after 1850s. And the most the important part is that the projections, if you see the projections 2050, 2100, is very alarming that even also in the northern hemisphere, 4-degree rise in temperature is there. That means all the issues I mentioned, this will be, we have to rethink. And drought also, we have seen that different parts of central India and Kerala already is a huge drought, and it has been projected that in climate change, that's more drought will be there. And if you see another part that in the left hand side, if you see that the sowing of rice, which is started from June to July, we have taken 50 years data and we have seen how many breaks are there. You will be wondered to see that in July and August there is huge breaks are there, which is making a lot of concern. And also in the right hand side, we made the projections of the GCM's model, and it is showing that though the central India something is drought may not be as prevalent, but the South India, North India, they will be having a huge drought in future. So similarly, the floods, which I was telling, there's seawater intrusions and flooding. So these will also has increased, and it has been projected to increase also. Then the clarion call from United Nations and WMO is that they are telling that to all the continent, early warning system has to be taken in a very priority areas for the extreme weather. That's why that Secretary General of UN and WMO tell us they are working that next 5 years how these extreme events, particularly in South Asia, can be controlled or minimized. And another perception is there in South Asia that traditional knowledge, still if you are going to the village, farmers are using the traditional knowledge, which was working 40 years back, but it has been already been evidence that traditional knowledge is not adequate. They have to given a very scientific kind of informations. You see, one of the interventions is that in South Asia, that operational agromet services is going on. There are some degree of perfectness is there, but all the countries in South Asia, they have started, and they are, interchanging the information to different kind of platform with World Bank, with WMO. So we are very hopeful that when this operational agromet service will be in full swing, then whatever the issues will be coming future, that can be controlled. And now one of the intervention is that multidisciplinary approach that has been taking place, which is knowledge based, and also which can be scaled to the different parts of the South Asia. So some of the interventions I'll be showing that it is the watershed management, is the water budgeting, groundwater mapping, direct seeding, promoting water efficiency system, crop intensification, alternate wetting and drying, and also the diversification of the crops. So what I feel that these are the interventions should be coming in a big way in South Asia with some kind of World Bank, WMO, and some forum. So then it will be very, very effective. And some nature-based solution which we are trying. One is the grazing optimization, then improve rice cultivation, crop nutrient management, conservation agriculture, trees in the cropland. I think this kind of interventions is coming in a big way in South Asia to help this farming community in a big way. Now, these are some of the flood interventions in South Asia. A number of varieties has been grown which they can withstand this flood. And also in different South Asian countries, they have developed the flood forecasting system. Even EC mode is also is with South Asia. So we are very, very, Bangladesh has done wonderful job. In India also, QPF method is using. So maybe in near future, all the countries will have a very sound flood forecasting system in South Asia. And drought monitoring, now 150 drought monitoring indices are there, but SPI, SPEI, and some of the anomalies are doing wonderful job. So all the countries in South Asia, somebody has started, and some they are starting how to drought monitoring so that they can appropriately give the adaptations and mitigation plan and short and long term. Another very important thing is that what I was mentioning, that you have to use the water in a very, very scientific way. That's why there are a number of satellites are there, and Indian Remote Sensing Satellite and Space Application Center, they have already developed one system where based on the satellite you can make a very precision agriculture. So hopefully maybe next couple of years this will be shared with all the South Asian countries, and water will be used based on satellite data as a precision agriculture. Now, these are some of the examples of why we are going operational agriculture agromet services. So we have showed that by using this kind of information in terms of extreme events, in terms of benevolent or malevolent weather, how this non-AS and AS is so we have seen number of places in South Asia, particularly Bangladesh and India, that implementation of AS has contributed a lot into the GDP and the farmers' profitability. Now we are coming whatever we are talking about, it depends on the policies of the government like that. So what we have thinking that all the South Asian countries that already we have organized two sensitization program, one with the Afghanistan and one is the Nepal, and shortly we'll do in Bangladesh and also Myanmar. So we are discussing about what should be the policy of doing this kind of intervention. First policy will be that subsidy-based kind of irrigation is not a proper solution. So that has to be looked into very highest priority. Second thing, that diversification of crops like nutricereal, sorghum, millets, maize, soybean, and vegetables have to be more popular. And second thing is that, whatever we will be doing, that should be linked with the market. Then only this kind of interventions will be making more popular. And World Bank has a number of projects in Bangladesh, in Sri Lanka, in Nepal, and other countries. So our request will be that in World Bank, so they can also look into the practical insight of this problem, and they can also help what it could be the exact policy. And very, very important is that participatory irrigation management resource farmers. So what we have seen that if you come to India and Bangladesh, you have seen different groups have been formed who themselves will decide that where, how the irrigation should be given, and it has been demonstrated well. So my last slide is that how we should go way forward. We all know that climate change and climate variability is very, very serious issue in South Asia, and this has been well in this international seminar. So first and foremost thing that this is a serious issue. Then second thing that for making this into a sustainable water use, we should have a long-term kind of planning so that we can face these challenges of inadequate water or food supply. Another very important thing, some of the countries has been done that they have mapped the water productivity in a very high resolution scale and coarse resolution scale. I think that India has done a number of places. I will be requesting that in other countries, they should map that water productivity, and based on the water productivity, they should switch over from sugarcane and rice to other remunerative option. Very important is the political economy. We can, as a researcher, and we can, as a philanthropy, we can tell that this should be done, that should be done. But political economy and politicians and politics, this should become, and they should understand the importance of this issue, and they should frame this policy in such a way that this should be a farmer-centric, so that farmer could save the water and they can increase their food production. My last appeal will be that more of in research part, in South Asia, maybe some of the countries has done wonderful job in application and maybe in agrometeorology aspects, but other countries, they are not as proficient as in the research in irrigation, agrometeorology, or like that. So whatever we are communicating to other countries, that a kind of collaborative kind of projects can be taken with the agriculture universities, with the agriculture organization, ministry, so that we can work on the irrigation practices and technology, drainage, water management, different kinds of tools for sustainable ecosystem management, breeding drought tolerant high varieties crop. I think that if this kind of research can be taken up in a very holistic way, I think that whatever the fear, whatever the signal is been given by the IPCC or COP26, I think South Asia collectively we can work onto that, and we can minimize the kind of climatic events, because you cannot change that impact of climate, though you have a lot of regulations. But these are the things this community can do, and we can stand up with the farming community, because they are unreached and unprivileged farmer in South Asia, which is different from other continent in the world. Thank you very much for giving me a chance to communicate some of the ideas. But I am open for any kind of discussion or question. Over to you.
Thank you, Dr. Chattopadhyay, for an excellent presentation, and you finished well in time. Any questions? Any comments?
I have something to ask Chattopadhyay.
Yes.
Chattopadhyay, you told about irrigation in agriculture in South Asia. I think you have been in Bangladesh for some time. Do you have any particular suggestion regarding irrigation in Bangladesh?
Yeah, I mean, not only in Bangladesh, if you see India also, if you're going to the villages and if they are cultivating the rice like that, so they are giving the flood irrigation. Now, it has been, I mean, scientifically established and it has been given to Indian Council of Agriculture Research that alternate wetting and drying means if you have a 15 centimeter depth of water and if you cultivate rice and alternate drying, your yield production will be as good as that, even more than that of the flood irrigations. So what I suggest for Bangladesh that similar practice is also going, but for the drought prone areas, at least this kind of I mean, what are kind of interventions that should be done? Firstly, that watershed management that should be done, and then water productivity map should be generated, so that where the water is at present scarce, that should be done, and where the flood irrigation will be there, I think a long-term planning can be taken up.
Thank you. I think Bari people can commented on that, please.
Hi, thank you very much.
Yeah, please switch
Yes,
on the
please.
mic, your mic.
You're on it, yeah, okay. Thank
Sorry. So it's very interesting presentation. Sorry, I joined in between while you were presenting. We have also been working in Bangladesh on climate change adaptation of farming systems for the past several years. And when we conducted surveys in the Bhaban region of Bangladesh, we realized that there is a certain extent of policy failure. Because in the initial years, the objective of the government is to focus on harvesting the groundwater for the sustainability of the livelihoods of the farmers. But eventually, the overdraft of the water there, it has contributed to a substantial, groundwater depletion over the years. And now there are fears that, the region may be undergoing a drastic groundwater depletion because of the lack of recharging policies. So why the drought monitoring and early warning systems are failing in foreseeing these kind of future policy failures because of the decisions that we take today? How do we overcome that kind of problem? If you have any suggestion, please inform us. Thank you.
Thing is that, as far as the groundwater lifting is concerned, from years, if you go for number of years, there was no restrictions were there. Anybody can use the groundwater of their own. But now, already that in US also it has been now all the water what people are using, that has to be taken into account. So I mean, that is what I am what in India government also thinking, also what I have given example for Punjab, that few years back, they started rice cultivation, and for rice it is a totally waterlogging in 5 centimeter or something like that. So they and huge area, and another problem is that this kind of system is business oriented, which they are ignoring the science, right? So what I feel that even in Bangladesh also, I think that I mean, optimization is very, very required. Suppose if you feel that alternate drying and wetting can serve your purpose, then you have to optimize and take the groundwater in that. So some control should be there. I think that even in these days, farmers are very, very sensitive. Yeah, they know that they are already experienced the signals of climate change and climate variability. So if they can be convinced through the intermediaries that this is very precious issues and you have to optimize this thing, I think that even Bangladesh farmers are very, very knowledgeable. They will be cooperating with this body and other institute and come out with a very good solution, and future and looking that thing in a very, very futuristic way. But again, a consortium is required for that. Bangladesh government, then Ministry of Agriculture, body and other institutions, they make a consortium and make a kind of awareness and sensitive program so that this will be done. This cannot be done in a very unidirectional way. Over to you.
Thank you. Another general question, but it is not to you, it is on the floor I am leaving regarding the irrigation. When dry season, farmers irrigated, they use the deep tubewell. You know, understand that Bangladesh, they use the deep tubewell. When they start deep tubewell, there is a pond besides around the field. The pond become dry up. So they cannot use the water from the ponds. You understand what I am telling?
Yes, yes.
When they start the deep tubewell of the field, the ponds around the field become dry up. So what is the way out of this situation?
Two things are very important that, here what I was mentioning about the water harvesting. Okay, because in India also that Central Water Commission, they have taken extensive projects that about, one is that building up the reservoirs and canals, but they are giving very emphasis on the water harvesting structure. I think that number of ponds and water harvesting structure should be there, because if you have a wheat, you have to give 5 irrigations, and if you are rice, you have to make water logging. So one pond nearby side may not enough or like that. So what I prefer that you have to make a culmination of the irrigation system. One is that pond, one is that your groundwater, like that. So you have to make a very strategy of doing, because you have already experienced it has been tried. Okay, so what could be the way out? So these are the way out with the available infrastructure, with available funding you can do. Okay, because there is no, you cannot create rain, but you can reserve that particular rain by water harvesting structure. And another thing I was mentioning that when they are using this kind of pump or like the flood irrigations they are doing, which is not required. So this kind of planning is required to do this thing. But it is not a straight cut kind of solution, but this has to be worked out.
May I just add to it? I think one of the programs which the Government of India has initiated is the artificial recharge of groundwater, and they have started in a big way investing in that. That takes care. The other thing is that I think we have been talking about that we should use our water judiciously, and so we should not irrigate more than what is required. And if we can combine all these things, unfortunately, because of whatever reasons, there is no disincentive for using excess water anywhere. And that is one reason why, as Dr. Chattopadhyay mentioned, in Punjab it is happening. But it's a serious issue, and I think unless at some stage we start thinking of water as an economic good, it's an economic good and it should be treated the way, probably then we will start realizing the importance. Because there's a famous saying that we realize the importance of water when the wells run dry, we don't realize the importance of water when the wells are full. So that is the issue. Anyway, thank you, Dr. Chattopadhyay.
I want, sir, I want to finish it up one thing, that whenever we do agriculture or we do irrigations or like that, cost of cultivation is a very, very big issue. Okay. Whenever you use the farms, that ultimately it is going to the how much cost you are doing for 1 hectare of land. So what Government of India has started solar pump system, which is very, very remunerative, and they won't spend much of the thing. So I think that one of the recommendations may be made in the international seminar that in Bangladesh, if possible, that solar system can be introduced, so that which is easily to handle. Only the initial installation will be that Bangladesh government is using huge money in so many aspects, but this can be one of the point can be taken up as a kind of recommendations. Over to you, sir.
Thank you, Dr. Chattopadhyay, for taking out time and being with us. Thank you, Dr. Chattopadhyay, for being with us from all the way from India. Now we move on to the next presentation. Next presentation is by Dr. Sen, Problems and Prospects of Solid Waste Management in Bangladesh. So, Dr. Sen, please. I request you to wind up in about 15 minutes because we are almost we are 45 minutes behind. Dr. Sen, please. Dr. Sen would be presenting on problems and prospects of solid waste management in Bangladesh.
Honorable Chairman and distinguished scientist, welcome to all. My presentation is Problem and Prospects of Solid Waste Management in Bangladesh. I am Dr. Ranjit Sen from Bangladesh Agriculture Research Institute. You know, the solid waste is one of the problem and it contributes about 5% of greenhouse gas emission in Bangladesh. Compared in globally, it is 3 to 4%. The cause is multi-dimensional because you know the urbanization in Bangladesh I am showing before the independence of partition of India and Pakistan, the Bangladesh, the then East Pakistan, its population is very low, urban population is very low. Only 4% people live in the urban areas. But due to increase of time, it is now about 40% people live in urban areas. So the population density in the Dhaka City Corporation is about 15,000 square kilometers, 15,000 people in a single square kilometer. But in average, only 1,200 people live in Bangladesh per square kilometer. So the urbanization in Bangladesh is rapidly grows up due to many reasons, because the education, job facility, medical facility, everything are concentrated in the urban areas. So people comes from the rural area to urban area, and the urban population density is increasing, and it creating huge solid waste disposal problem. I am showing in the table the urbanization pattern of Bangladesh and as well as in the Dhaka city. Now about more than 2 crore people are live in Dhaka. It is a not too big city. And the population, urbanization population in 1951, it is only 4%. But now it is about 40% and it will reach 50% by 2030. So the total population, you know, the Bangladesh is 17 crore. So it is a huge problem for the local government of Bangladesh to manage the solid waste disposal problem. You know, in 1991, only 20 million people are urban, and in 2025, it will 78 million people live in the urban, and the waste generation rate, that is in 1991, it is only 0.31 kilo, that is 310 gram per capita per day waste are generated. But now it is in 2025, it will be 0.60 kilo per capita per day, because you know that our income is, GDP is increasing. It is in 1991 only $220, and it will be $3,055 in 2025. As the GDP is increasing, our lifestyle is also increasing, and people are purchasing more luxurious goods and others consume more foods. So waste generation is also increasing. And many kinds of waste are generated. You know, the food waste, the mainly about 80% are food waste. Also plastic, polythenes, glass, ceramics, metals, paper and clothes. These waste are generated and these are waste. One survey work we had conducted at Gazipur City Corporation. The waste collection pictures I am showing. And what is the composition of Bangladesh, the solid waste? You know, about, we compare that waste, composition of solid waste depend on the income and family size of the family. If you consider high income group family, their income is near about 1 lakh taka, the food waste is 74%, because they are spending more money to the luxurious goods like clothes, papers, plastic, polythenes and others. If consider the low income group family, they are, as their income is low, they are investing almost all the money to purchase their food waste, and it is about 80%, more than 80%. So the solid waste composition depends on the income of the family. And also, you know, the characteristic of the food waste, to manage the solid waste, it is important to know what are the properties or characteristics of the waste. For food waste in dry wet basis, it is characterized about 76% moisture in food waste, and their low heating value, that is 890 kilocalorie per gram, and the organic matter content is high. Carbon nitrogen ratio, carbon also is high, nitrogen 1.08, and also some amount of phosphorus, potassium and sulfur, and CN ratio, which is important for the composting, for use as agricultural land, it is suitable for composting, and CN ratio is 38.5. And about the urban waste, you know, the present situation in our country, the whole waste, I mentioned the many types of waste, and whole waste are keep in the same bin in house, and that is the main problem. So, and then the mixed waste are collected, dumped into the dustbin, and the local government conservancy service, they are keeping the truck, no source separation, organic waste and inorganic waste in same truck. They are keep it in the transportation and dispose to the landfill, and these landfill are also not the well designed sanitary landfill. And this I am showing the most of the waste I show you the high organic matter characterized, it is about 80%, and high moisture content 70%, and low calorific value. So low calorific value restricts its use as a fuel or heat generator at biogas. So the Bangladesh waste, most of the organic waste is suitable for composting, vermicomposting and others. And the problem is due to huge solid waste, the water pollution, it creates leachate or comes to the surface water, and that pollutes and spreads of disease. About 80 vermins of the disease comes from the solid wastes. And greenhouse gas emission, you know that waste sector also contributes 5% GHG emission in Bangladesh, and foul odor comes from the waste, and air pollution occurs, and we also, there is shortage of landfill, so, and this is the problem. So in another thing, new waste streams comes from, because the electronic waste, the new type of waste, it is emerging 20 years, and it's increasing day by day, and its management is completely other from the other waste streams. And also the hospital or biomedical waste, that is increasing also day by day, and its management is also separate. And the relation of the waste generation rate with number of family, we show if the number of families member is higher, then total waste generation, and is also in high income group, I found that total waste generation as well as waste generation rate, both are higher in high income group, as they consume more food and more luxurious goods and others. And the low income group, their waste generation rate is lower, and it is 0.3 kg per capita per day. So relation of waste generation rate with monthly income, if the income is high, then the waste generation rate is also high. If the income is low, then waste generation is also low. And what is the problem of the solid waste management in Bangladesh? Because we do not practice the 3R approach, that is reduce, reuse and recycle. The 3R approach is the most popular approach in solid waste management, and the most favored was the prevention, not to generate waste, and then the minimization, that as low as waste we can generate. Then the third option, if possible, then waste we can reuse, and we can polythene bag we can reuse 2 times, and then fourth option is recycle. If possible, then we can recycle the solid waste, and then energy recovery. We can from solid waste we can generate biogas and electricity generation, and last option is the disposal in the landfill. So this hierarchy of waste we are not following. We just only dispose in the landfill or dumping in the roads and others. Lack of source separation in household waste. We know that both the organic and inorganic waste are put in the same bin in every house, so it is difficult to separate. And the low waste collection efficiency is also a problem. In the city towns I am showing here, and the waste generation, this column, collection efficiency is almost 43 to 45% in average, and disposal I am showing in this column, and greenhouse gas emission, 8,813 carbon dioxide equivalent ton, carbon dioxide equivalent per day are generating from these solid wastes. So, for the global warming aspect, we have to minimize the solid waste disposal problem and convert the waste to resource compost, biogas and others. And fourth problem is shortage of suitable land for landfill. You know, the Dhaka city, there is shortage of high land for landfill. We have 2 landfill in Dhaka district. One is Amin Bazar and another is Matuail. And these landfills are occupied very shortly. In 2025, we need about 500 acre of land for the landfill. If the 100% solid waste are we collect, so in our country, in every city, we do not have enough land for the landfill disposal. And another is irrigated waste recycling. You know that this plastic waste we can reuse it, and the polythene we can recycle. And in many countries, fuel oil can converted from polythenes. So, and a sixth problem is environmental concern. That is, about 40 diseases comes from the solid wastes. This is a health and sanitation problem. And the bad foul odor and greenhouse gas comes from the solid waste. It is air pollution, and the water and soil pollution. Leachate comes from the groundwater, surface water, and then thereby adjacent groundwater. That is, the open dumping is the main problem of solid waste disposal in our country. And what is the prospect or what is the solution of the solid waste management in Bangladesh? First, we have to consider the 3R approach, that is reduce, reuse and recycle. First, we have to reduce the amount of solid waste. Then, if possible, we can reuse some portion of the solid waste, and then we can recycle some portion of the solid waste, and then we can recover energy and others from the solid waste. And the last one, we can dispose in the landfill. So, the promotion of source separation of waste, if we have 2 separate bins in our every house, the green one may be for the organic waste or food waste, and if we trained our maid and our housewives to keep the waste in the green bin, and the undecomposable waste we put in the yellow bin, then the source separation in the house will be completed, and the organic and inorganic waste are disposed to the separate dustbin and others. The probable use of waste fractions for food waste we can convert in compost, tricho-compost and others. It is suitable, and the crop residue also we can combust as a fuel. And polythene we can process, reuse and recycle, and some fuel also fuel oil can generate from polythene. Plastic we can use as fuel and also process and recycle. Cloth waste we can biodegradable as used biodegradable, and paper we can use as fuel and we can recycle it. Glass and ceramic we can recycle, and metal we can use as recycle it. So the promotion of organic waste utilization, about 80% waste are organic and for food waste in Bangladesh. So we can use as animal feed. You found that some goats are eating from the food waste at Mymensingh municipalities, and also the dogs and the pigs are also taking some food waste. So food waste can minimize, and we can prepare also the compost and from organic wastes, and you know that this is the windrow waste composting, and in vessel is small quantity of waste we can compost in vessel composting, and we can also in decentralized approach of composting using carbon credit, we can prepare some compost plant in the every ward of the city corporation, and then we can composting it. The prospect of solid waste, the third option is biogas and biomanure. We can prepare biogas from the solid waste, and after getting the biogas, we can collect the bioslurry or biomanure, and it is suitable for the crop production. And the third option is, fourth option is fuel briquette. From the agro waste, we can prepare this densified fuel briquette, and it is in our country the rice husk briquette is popular, and we can recycle it. You know that this is a coconut dust, coconut waste, and we can prepare just like a cup from the coconut waste, so we can recycle or reuse it. So the last is a integrated solid waste management approach we have to follow. Solid waste generate from the house, then it convert to the we can some portion convert to the composting and biogas plant, and some electricity generation, landfill gas collection, and recycle we can, reuse we can, and the last portion which is not any use, then we can dump in the landfill, and which will be the environment friendly landfill. So the conclusion is solid waste disposal is a serious problem. About 80% waste are food waste in organic in nature and characterized by high moisture content. Food waste can be converted to organic manure through composting, and inorganic waste like polythene, paper and other waste can be reused and recycled, and through this we can minimize the waste disposal problem. So waste is wealth and trash is cash. So lastly I am telling you, thank you.
Thank you, Dr. Sen. So we can have maybe one or two brief, yeah, Dr. Gaurang, please.
Dr. Sen, very interesting presentations. I was actually wondering how the Dhaka city is managing the solid waste, even if the per capita is not so high, but you know, the population is big. So I was wondering, and as I see in the street, at least this is good compared to what we have in Kathmandu. So I was thinking, and you probably have a better you know, management than we have in Nepal. So I'm wondering, and the initiatives taken by Dhaka city is very appreciable. But still, as you said, that there is a long way to go. But I was imagining that you must have some strategic long-term solution already by the government. So what that strategic plan is, that is one. And I have heard that you have good regulations of non-degradable matters already as per policy. And what is that? And is there any, you know, solid waste been involved into this recirculation economy already?
Hello?
Yeah. Is that
solid waste?
Yeah.
So I am telling the JICA and others providing some monies to the Bangladesh government, and the well-designed sanitary landfill are preparing, and you know the solid waste is generated from the main problem is it is mixed, organic and inorganic mixed, but at the village, at the vegetable market, the wastes all are organic. So you can undoubtedly the whole waste you can convert in the compost and others. And at Kachpur bridge near, there is a big waste composting plant. They are collecting organic wastes from the Kaurun Bazar, which is 100% organic. No need to separation. They are preparing compost from and other cities also the vegetable waste from the market. Some NGOs and others, they are collecting and preparing compost. You know that our country, the soil are deficit in organic matter. So we know we need the compost fertilizer. So awareness is going up, I think, growing about the solid waste problem in our country.
More?
Okay. Just add some comments on Joya's questions and Ranjit's reply. As Dr. Shen mentioned about JICA's program, these 2 hour, what do you call them? Mayor, 2 mayor of the Dhaka city have taken in action. That's why you have seen the less material in the road. It is taken well. But still we cannot separate the waste of solid waste and vegetable waste. It is one big problem. Another big problem is to dump it. There is 2, he mentioned, one is in Amin Bazar, another is in
Amin Bazar and Matuail.
So it is not enough for this Dhaka city. We are looking for others also. And intermediate, the 2 mayor, but 1 mayor was very active, he died, Anisul Haq, or later Anisul Haq. He have a designed, or with the consultation with experts in the world, to recycle our waste materials, bring it into the economy. So it is in the pipeline. Even in the toilet waste also be used in our economy. So that is in pipeline. Thank you very much. Announcement from the organizing committee. So we want to stop this session now. We continue this session after tea break. Khairul Alam, I request you to the first presenter in the next session, not in this session. We want to keep the time. 10:30 was our tea break. We want to break. It is already late. We go in the downstairs, we finish our tea. In 15 minutes, we will come back here. It's okay? Thank you. Let's go for a tea, yeah?
Thank you. Yes, we have a tea break for 15 minutes.
2008.